Hi guys, welcome to today's tutorial. Today we'll be looking at a topical topic in our mathematics, and that will be exponents and logarithm. Okay, let's start with what do we understand by exponent, what are exponents and what are logarithms. Now, most of the times, students tend to look at it as a big word, but let's look at it like words and opposites. Okay? Now, if we say go forward, the opposite of go forward is come back, right? Now, just like going forward and coming back are words and opposites, that's how exponents and logarithm are. Okay, exponents are about repeated multiplication. Okay, how many times a particular number is multiplying itself, that's exponents. Say x raised to power 2, that is x times x. All right, that is exponents. Now, while we talk about logarithm, they're about figuring out how many times you have multiplied that number. When we talk about log 10 is 1, that means 10 times 1 is giving you 10. So it's like exponents gives you how many times a number multiplies itself, and the log is giving you how many times a number divided by its base would be. Just like we have 10 divided by 10 would give us 1. 10 times 1 is 10, like forward and backward. Okay, and once you get that connection, once you get that understanding, you'll see that most of its rules, because there are basic rules for both exponents and your logarithm, becomes easier to understand. Now, let's look at exponents, also called indices. All right. Now, an exponent tells you how many times a natural number is multiplied by itself. Okay. Now, example is 2 raised to power 3. Okay. 2 raised to power 3 is 2 multiplying itself 3 times. That is 2 times 2 times 2. Okay, and 2 raised to power 3 is 2 times 2 is 4, 4 times 2 is 8. So 2 raised to power 3 is gives us 8. Now 2 is our base, while 3 is our exponent. Okay, now let's look at some basic laws of our exponents. Now we have the multiplication law, where if our bases are the same, then the exponents are added. I take that again. If our bases are the same, then the exponents are added. If the bases are not the same, you can't add the exponents. Say for example, we have 2 raised to power 3 times 3 raised to power 2. Now, the bases here are not the same, so we can't add these exponents. But if we have 3 raised to power 2 times 3 raised to power 5, then this becomes 3, since we have same base, raised to power 2 plus 5, which gives us 3 raised to power 7. So we need to understand that when to apply a multiplication rule or law when we have same bases. Okay, looking at the division law, all right, when we still have same bases, all right, and different exponents, we do what? We subtract. Remember, multiplication talks about adding of your exponents, while division talks about subtracting of your exponents. Now, looking at our power of powers, all right, now a single base with an exponent all multiplied by another exponent. Okay, a single base, say 2 raised to power 3, all raised to power 2. Now, in this case, we do what? we multiply our exponents, which gives us 2 raised to the power 2, 3 times 2, which is 2 raised to the power 6. Okay, so that's what our powers of power is talking about. Now, powers of a product. If you have two numbers in your parentheses, all being raised to a power to an exponent, then that exponent which it is being raised to is shareable among your two numbers. Example, if we have 2 times 3 all raised to the power 2, what this simply means is that we can rewrite to be 2 raised to the power 2 times 3 raised to the power 2. Now, this exponent or our power here is shareable among the 2 and 3. Now, the zero exponent. Now, as long as our base is not 0, anything raised to the power of 0 gives us 1. Any number, any figure, any alphabet raised to the power of 0 gives us 1. Now, the negative exponent talks about when our exponent is negative, now we introduce 1 divided by the positive of our question. Now, exponent rules are mostly about keeping tracks of multiplication in a shorter way. So instead of having 3 times 3 times 3 in 5 places, we make it look short by saying 3 raised to the power 5. So if you have it as 3 times 3 times 3 times 3 times 3, in indices form or in exponent form, it becomes 3 raised to the power 5. So this looks shorter than this. Okay, now looking at logarithms. Logarithm, on the other hand, like we said before, is the reverse or opposite of exponents. Okay, so if we have 2 raised to the power 3 equals to 8, now how many 2's can we find in 8? Okay, now that becomes a log 2 the base 8 equals what? 3. So how many 2's, how many times will 2 multiply itself to give us 8? That becomes the question. Okay, how many times will 2 multiply itself to give us 8? So you say it's a reverse. The other way, we say how many times will we multiply, will 2 be raised, okay, to give us 8? Now we are looking at how many 2's can give us 8. So that means 2 raised to what power gives us 8. That is what we are looking for. So if we look at it, it becomes 8 equals to 2 raised to the power 3. Now, looking at our basic laws, remember in logarithm, in exponents, we looked at the multiplication law. When they have same basis, we do what? We add. The division law, when they have same basis, we do what? Subtract our exponents. Then the zero law, once it is not equal to 0, every other thing raised to the power of 0 gives us 1. The negative, when our exponent is raised to the power in minus, we introduce 1 over the positive of that exponent. Now, the powers of power, we look at multiplying the outside exponent with the inside exponent. Then the powers of product, we looked at sharing our exponents among our two numbers or digits within our parentheses. Okay, now looking at the laws of logarithm. First is the product law. Alright, our product law says log A times B gives us log A plus B. Okay, in exponents, we have it as A raised to the power n times A raised to the power n to give us A raised to the power A plus n. Okay, now in log, we are having it as log A times log B, sorry, log A times B, log A times B to give us log A plus log B. Okay, now same for the quotient. When we have log A divided by B, it gives us log A minus log B. And for our power rule, all right, our power rule is log A raised power n. Now this n comes down here to give us n log A. So for example, here if we have log 3 times 5, so this becomes all in this 10. All right, so this becomes log 3 times plus log 5. Remember, they are all in base 10. Okay, so for the quotient here, we have it as log 10 over 2, all in base 10. That gives us log 10 minus log 2. Okay, and for this, if we have log 10 raised power 2, that gives us 2 log 10. Okay, that's the application of those three laws. Okay, so log of 1, log 1 equals 0. Okay, and log of same base gives us 1. That's like we have log 10 equals 1, log 2 equals 1, log 5 equals 1. Okay, so log 1, log 10 of 1 equals 0. Simple way to always remember is that log turns multiplication to addition and division to subtraction. So when you bear in mind that in your log it turns into addition, multiplication turns into addition, and division turns to what? Subtraction. Okay, now let's look at the connections between our exponents and log. It says they are inverse operations. Like we said from the very beginning, exponents are and log are like moving forward and coming back. Okay, now exponents form ax raised power y, while our logarithm form is log ay equals x. Now you can see that there's a connection between them. We have a raised power x equals y, and on this other hand, we have it as log base a gives us y of the power to which it is raised. So a here is our base, x is our exponent, and y is our answer. Now in log, a is still our base, y is our answer, and x gives us our exponent. Okay, if you understand one, you can always switch to the other. So if we have, let's say 3 raised power 3 equals 27. So switching it to logarithm form, we have it as log 3 27 equals 3. You can see this is our base, our exponent, and our log, and our answer. So here in logarithm form, we have it as our base, as 3, our answer, and this becomes our exponent. Now let's look at some examples. We have simplify 3 raised power 2 times 3 raised power 4. Now, which law are we going to apply here? For this, we apply the first law of our exponent, which we looked at as the multiplication law. Since we are having same basis, we can apply the law of 3 raised power 2 plus 4, and which gives us 3 raised power 6. All right, which is 3 times 3 times 3 times 3 in 6 places. Okay, now we have simplified log 2 plus log 5. Okay, log 2 plus log 5, since this is addition and they are in same basis, we can turn it to log 2 times 5. Remember, when we have log a times b, it becomes log a plus log b. So it's a two-way method. So if we have log a times log b to give us log a plus log b, when we have log a plus log b, we can reverse it to be log a times log b. So in this case, this becomes log 2 times log times 5, which gives us log 10. And remember, you have log 10 equals 1. Remember, the log guiding that is log AA equals 1. Log of same product, log of sameness, log of your same base, log of same base gives you 1. Okay, so on this, your assignment is to simplify 5 raised to power 7 divided by 5 raised to power 3 and explain the rule used in getting your answer. Alright? And also express 4 raised to power 3 equals 64 in a logarithmic form and explain what you understand by your solution. So I expect to see your solutions in the comment section. All right, if there are any challenge or questions, you could also put them down in the comment section.
Hi, I'm sure you enjoyed the video you just watched. To see more content as that, preparing you for your upcoming exam, make sure to smash the subscribe button and turn on notification. Also, remember that you can use the comment section to send us your questions or your inquiries, and we are happy to take them. I'll see you in the next video. Bye.